Hello everyone, and welcome back to the Kohi game engine series. Today we are going to tackle input, and we're going to get started right now. Really quick though, I would like to take a quick second and thank the partners of the channel, Eearslya and Wensheng. The partner is the highest tier of supporter on the channel. And so I just wanted to say thank you to our partners as well as our other supporters that are listed here on the screen. So if you're interested in supporting the channel, there are a couple ways to do that now. First off, I have channel memberships available. You can access that by clicking the join button below this video. I'll also provide a link to a video that I have describing the memberships. And I also have a newly launched Patreon page, which is patreon.com/Travis Vroman. And I've set that up because I've had a few requests for that versus the YouTube memberships. So if it's easier for you to use that instead, that is now available for you. So thank you all very much for your support. It is greatly appreciated, and I will be rolling a lot of that back into this channel. Okay, so input. Let's take a second and define exactly what our goal is here. So input is something we're going to be handling in multiple phases. First, we are going to cover basic keyboard input and mouse input, so that once we actually start creating things like our renderer and whatnot, we're able to move around our scene just by pressing keys on the keyboard and moving the mouse about to adjust the camera, things like that. We don't want to have to stop and do that stuff down the road, so I'd much rather just knock it out now, at least a basic version of it. So that's what we're going to do. Now, there's two main parts to this that are going to go into this initial system. There's the input system itself, which is going to be responsible for handling sort of the key press events and the mouse input events and defining all the data structures we need and handling state updates, things of that nature. And then there is the OS specific portion of this, which is there's going to be a little bit of code we're going to have to write for Windows, and then there's going to be a little bit more code that we're going to have to write for Linux and eventually Mac when we get to it. And that's because each of these systems has its own slight variation on input. Now, obviously, input is also going to cover gamepads later on in the future. It's also going to cover touch screens, but we are not going to implement those things, at least in the initial version of this. So, with all of that out of the way, what we are going to cover in this video is the first part of that I mentioned, which is creating the actual input system itself. And then after that, we'll go ahead and hook it up to the OS layers or the platform layer. And from there, we'll actually tie some things in to test this whole thing out. So with all that out of the way, let's go ahead and get into it. So we're going to want to start by creating a new file in core, and we're going to call it input.h. Obviously, we'll start off with our pragma once and defines.h as always. And next we'll need to define some things. So when you're handling input, you generally want to define the various methods of input and their various controls. And what I mean by that is we want to have some sort of universal declaration of a mouse button, for example, or a mouse wheel, or a key on the keyboard. We want to define that somehow so that it's universally the same no matter what platform we're on or where we are in the engine. So that way it doesn't have to worry about operating system specific codes or anything like that. So the very first thing that we're going to do is we're actually going to create an enumeration for our mouse buttons. And initially we're just going to call that buttons, right? And so buttons is going to represent our mouse buttons. And we'll have a left, right, and middle button, which is basically when you click on the mouse wheel. And then max buttons here declaring how many we actually have. We might wind up supporting more than this in the future for gaming mice, things of that nature. But for now, we're just setting up a basic system. I want to keep it nice and simple for now, so we can always extend this in the future. So the next thing that we're going to want to define is keys on the keyboard. And this is where it can get a little bit monotonous to define this thing, because as you can imagine, there's over 100 keys on your keyboard, and having to define each one of those things one by one is kind of monotonous and error prone. And so what I actually am going to do in this case is I'm going to make a quick macro that allows us to define a key. And we pass the name and the code. And this prepends a key underscore to the name and then sets it equal to a code. Okay? And we're basically going to create an enumeration, and then for each line of the enumeration, we're going to call this define key, which will actually spit this out for us. So next, I'm going to paste in a giant enumeration that we're going to call keys. And as you can see here, we have a bunch of them defined. Now, what are all these codes? What do these things mean? Where did I get these from? Well, if we take a quick look at a website that I use quite often called ASCIIchart.com, it gives us a basic listing of some of the ASCII character codes that are used, as well as what their decimal ASCII equivalent is. So for example, a capital A is 65, a capital S is 83. And these happen to line up perfectly with the key codes that Windows actually uses when pressing these particular keys on the keyboard. So this is actually a really good starting point. But obviously we have a lot more keys on the keyboard than just these things. So what we're actually using here is we're using the same keys that are defined in Windows, the same codes that are defined for these keys in Windows. And the reason for this is because A, those codes line up for the letter keys at least, and some of the number keys, things like that, they line up with that ASCII chart pretty nicely. So we get that right out of the bat. The other reason for that is they've actually done a pretty nice job of defining things like the number pad keys, all these subtract, divide keys, the F keys, all these other keys that we potentially and probably will wind up using. And this allows us, at least for the Windows platform layer, to map directly to all these key codes very, very easily. Now this does mean that we'll have to translate on other platforms, but I'm actually okay with that, because Windows is actually going to be the first thing that we're going to implement this on, and then we'll go ahead and make the translation within the Linux layer to use these keys instead. So these are the codes that I've used. So right here we have the name of the key and then the code for that particular key. So you will note that escape is 0x1b, which actually is 27. That's the common code for the escape key. And so all of these are actually, they all line up to those decimal key codes, okay? And so that is pretty much that, right? So again, I'm not going to walk through these one by one. It's just much easier if you guys just grab from the repo and paste this directly, because it's not worth really spending any more time on than that. Okay, so now for our inputs interface. So as with a lot of other subsystems, we have an initialize and a shutdown. Pretty straightforward stuff. I don't think that needs much explanation. However, we also have an update function for our input. And this takes a delta time, which we may or may not wind up needing, but I want to include it in case we do need it at any point in the interface here. And this will be called once per frame. Okay, and we'll come back to the reasons why that is in a bit. So the next thing that we need to know from our input system is we need the ability to query the state of a given key. So a key for a particular frame could be pressed, it could be released, so in other words, the down or up state. It could also have been pressed in the last frame but released, or released in the last frame and pressed now. And so what we actually need to manage here is two states, sort of a previous state and a current state of each individual key. And we want the ability to query those separately because, for example, we would want to know when a key was just pressed to eliminate repeats, for example, or we want to know when a key was just released. Things of that nature. We want the ability to query that. And so in order to be able to query that, we actually need four functions. We need a is key currently down, which takes the key code and says, hey, is this currently down? The same is true for up, and all these return a Boolean, by the way. And then was key down or was key up, which is basically the previous frame's state, okay? And so as you may have guessed, this input update takes the current state and copies it to the previous state on every frame. So that way we have both of those states every single time we update, and we can make these queries accordingly. Okay, and of course these particular functions here are exported because we're going to want to use those in our game code, whereas these guys here are not, because they should only be called internally by the engine. Okay, So one more thing for keys is we need the ability to process a key. And this is actually what we are going to call from our platform code, our operating system specific code, where we say, here's a key and whether or not it was pressed. And this will be used to update the current state of a key based on what is passed here. So again, this is not exported because this is only internally used by the engine. Okay, and this pretty much covers keyboard input. Pretty simple and straightforward stuff. Mouse actually has a little bit more state to it, just because of the nature of it as an input device. So mouse input, we basically need the ability to check each button as to whether it's down or up, similar to keys, and whether it was down or up, similar to how keys work. So that's those four here. Of course, those are exported. So it works almost exactly the same as this guy. Okay, and then the next thing we need is the ability to query the current mouse position as well as the previous mouse position. So mouse position is another thing that we are going to track per frame. And that is so that we can track how much the mouse has moved, for instance, from one frame to the next, so that we can use that for things such as rotating the camera around, right? So that allows us to get that delta that we might need. Okay, and so those are our exported functions for our mouse input. And then finally, we have the functions that our platform code will call. And that is process button, which is similar to process key, but for mouse buttons. It takes a button and whether or not it was pressed. And then process mouse move, which takes an X and Y position as to where it is on the screen. And then process mouse wheel with a Z delta. That is the mouse wheel being scrolled up or down. So we could use that for camera zoom, for example, or scrolling a list box, things of that nature. Okay, and this is our entire input interface here. It's not very complicated at all. Obviously, as we add more device types, this will increase slightly in complexity, but again, we want to keep things lightweight and simple here. So this is what we're going to be dealing with here. So that pretty much covers it for input.h. So under core, we're going to create our C file. I'm going to call it input.c. And at the top, we are going to include 4 files. We want to include the event system that we created in the last video. We need some memory, and we also need the logger, right? So we want those 4 includes. And next, we actually need to create something to hold the state that I've been talking about. So we need both a keyboard state and a mouse state. So our keyboard state is actually pretty simple. It is basically just a flat array of keys that are Booleans. So all this is the key codes match up to our keys that we have defined here, right? Which goes all the way up to 193. So 256 will definitely cover us. Each one of these basically will be defaulted to false. And when the key is pressed, it gets flipped to true, meaning that it's currently pressed. So true means pressed, false means released or not pressed. Okay? And so that's all there is to keyboard state. Mouse state has a little bit more information. So mouse state has an X and Y for position, and then a small array for our buttons, which takes in the max button size here for our size of the array. And that is because we'll eventually be adding buttons to this, and then it'll make it very easy to expand this. But for now, it's 3. So it's basically an array of 3 buttons. Okay. So we have our mouse state and our keyboard state. That is what holds the state of those devices. But we're not going to create these directly, because if you recall, I mentioned that we have a current state and a previous state for each one. So technically we need 2 copies of each one of these. And the super crappy way to do this would be to just create them all as globals and call it a day. But I'm actually going to wrap these up in an input state structure, which has the keyboard current, keyboard previous states, mouse current, and mouse previous states, all wrapped up in a nice structure. And that way we can actually go ahead and create our internal state here and just reference that instead. So it just kind of wraps it up into a nice little package for us. And then of course we have something here to track whether or not this has been initialized. So the first things that we need to do in our input is we need to create our initialize, shutdown, and then our update. So Initialize comes first. So initialize is actually pretty straightforward. It might be what you expect. Now, I know I am zeroing the memory out here on a static variable, which is technically zeroed out by default. This is just me being pedantic. You don't have to do this. I'm just choosing to do it. We're also flipping the initialized flag to true, and then just outputting some basic information saying, hey, this input subsystem has been initialized. That is all there is to initialize for now. Shutdown is very simple. It doesn't actually really do much of anything at the moment except flip this flag to false. So I'm putting a to-do in here to shut down routines when needed. Eventually, when we set up a gamepad and stuff like that, there are going to be other things that we're going to have to stand up and create that will need to be torn down. And so when we get to that point, this will actually be much more important than it is now, but I want to go ahead and scaffold it, get it in there for now. Okay, so the update that I mentioned works exactly as I described before. Okay, so the one exception being we check to see if the input system has currently been initialized. In other words, have we called this guy? If not, it goes ahead and boots out immediately. It doesn't do anything. If the initialization has been completed, then all it does is it takes the current states and copies them to the previous states, right? And that is really all there is to the update for now. So this will be called every frame, and that's when we move the current state to the previous state for both the keyboard and the mouse. Okay, so if we go back to our input, we have our query functions, which I'm actually going to come back to because I want to focus on this input process key next. So if we go back here, okay, so we want to take our input process key, which takes a key and whether or not it's pressed. And we want to do a quick check to see if the state actually changed, right? Because we only want to execute this if we actually have a change in state. So we take our current state for that key and say if it's equal to pressed, or if it's not equal to pressed rather, then we know we have a change in the state of that key. So if it's not equal, first off, set it to equal. And then we want to fire off an event for immediate processing. So here is the first use of our event system. And so what this does is we create our event context. We set one of the U16s to the key code, right? And then we fire off a event key code pressed if it is pressed. Otherwise, we fire off a release. Okay, and the sender, we're not going to worry about a sender because we don't really care. In this case, we don't really have an instance of anything to pass along, so we're just going to pass 0, and then we're going to pass the context. And so we can both query the state after this, or we can listen for a key press event or release event and handle it that way. So we have both options available to us immediately. And that is all there is to input process key. Okay, so I'm also going to skip over these query methods because we're going to kind of do all these at once, and you'll see why here in a minute, and focus on these other platform input functions. So the next one we're going to want, of course, is input process button. So this works almost identically to how the key function works. So if the state has actually changed, then we go ahead and update the internal state and fire off an event saying whether the code was or whether the button was pressed or released. We pass nothing for the sender, and then context that we create here. Okay, so that's actually pretty straightforward stuff. The next one we want to handle is input process mouse move. So this takes an X and a Y, which are I16s. And again, we only want to process if they're actually different. So we check both the current state's X or the current state's Y to see if they're changed. And if either is changed, then we go ahead and fire off a message. Okay, and right here we can actually enable this if we're debugging just to make sure that this works. It just spits out some mouse position information. We can do the same thing up here in a bit to test and see if that's working once we get to that point. So the first thing we do is update the internal state by setting the current X and Y. And then we create a event context, which again is just going to set this time 2 U16. So we're going to set 0 and 1 to X and Y respectively. And then we're going to fire an event for the mouse moved type. Again, we're not going to pass a sender, and we'll pass along a context. Input process mouse wheel is even simpler because we don't actually have any internal state to update. So basically, whenever this one happens, this is not a queryable type of state. We can only register this by firing off an event and having something listen for it. So we may wind up changing that in the future, but for now, it doesn't really make sense to me. This is something that we would really want to handle as it happens. So for now, we're just going to hook this up by just firing an event. So now that we have all those done, we just need to fill out these real quick. So we want our is key down, is key up, was key down, was key up. So what I'm going to do is go back here, and first thing we're going to look at is our is key down, right? So we just pass in the key code. And first off, if we're not initialized, this is always just going to return false, because otherwise we're not going to have a valid state there anyway. So it checks to see if it's not initialized, and if it's not initialized, it's always going to boot out false. To check to see if it's down, if you recall, we want to check that current key's state, that it's equal to true, right? So we're just going to return that equals check. If it's equal to true, then it's down. So by proxy, to check if the key is up, it's going to be the exact same thing, except we're going to check it against false instead. That's all there is to it. Now, as you may have guessed, the was key down and was key up are the exact same function, except instead of checking against the current state, we check against the previous state. Otherwise, they're identical. So that's those four. Next, for a mouse input, it's going to look shockingly similar. We have input is button down. We pass the button, again, an initialized check, return false if it's not initialized. And again, we return the state of the button, the current state of the button rather, whether or not that is equal to true as to whether or not the button is down. The button up is basically the opposite. And so in this case, we're just returning false. And one thing I actually forgot to mention is by default, all keys and buttons are actually in the up state, right? And so I actually forgot to mention this as I was stepping through it. For the down check, the default state is false, right? So we want to return false if we're not initialized. But the up state should return true because by default, keys are up. Same is true for buttons, okay? By proxy, we have our was button down, which simply looks at the previous state, but runs the exact same checks. Okay, so that's these four and these four. So now what we need to implement is these last two, which is get mouse position and get previous mouse position. Get mouse position, simply if it's not initialized, it simply sets these to 0 and boots out early. If it is initialized, then it goes ahead and looks at the current state for X and Y and sets the value pointed to by the X and Y pointers to those values. So that's the current mouse position, and the previous mouse position is the same exact thing, except it looks at the previous mouse state. Okay, and that is all there is to the input subsystem, right? It's actually pretty straightforward stuff. It's more scaffolding of data structures than anything, to be completely honest, as well as, basically setting up our query functions. So now what we need to do is we need to hook up these three, right? And these other ones here will be hooked up in our OS code, so I'm not going to worry about that right now. But we need to hook up input initialize, input shutdown, and input update. And we're going to do that in our application. But obviously, before we can hook up that stuff to our application, we need to include it in application.c so that we have that available to us. Okay, so once we've done that, right after initialize logging, we will initialize our input. Okay, and then in application run, I mentioned that we need to call our update per frame, but we're obviously only going to want to do that if we're running and if the application is not currently suspended, because if it's minimized or something like that, we really shouldn't be listening for input, right? So if the application is suspended, we don't want to do that. So we're going to need to, somewhere in here, add our input. And there are a couple ways that we can handle this. We could add input first and process that first, and then process all of our game updates. But I actually prefer to do it at the end of the frame and use it on the next frame. I'm basically going to put a note in here to that effect that anything that depends on input should always be handled before the input is actually recorded. And so in this engine, it's basically going to be you'll check the state of input or make your queries here, and then input will be processed during the frame, but it won't actually take effect until the end of the frame, which means at the beginning of the next frame is when that input update will actually be available. And this is just the way that I'm doing it here. You could always change it if you want, but for consistency purposes, this is just the way that I prefer to do it. Okay, so that is our update. And then of course we have our shutdown, which needs to be right after event shutdown. Okay, and that is the life cycle of our input system. Now I can compile this and it will compile, but it will not currently run because we do not have anything actually hooked up to process this. And that is something I am actually going to put off to another video, because I know a lot of these videos have been very long recently, and I think it's about time for a shorter one. So the way I'm going to handle this is I'll cover Windows input in the next video, and depending on time, I may combine Linux input into that same video, or I may make it a separate video after that. We will see. But after the input system is actually finished, from then on, we will probably go ahead and jump into the renderer. So I know a lot of you guys are probably waiting for that, and that is where we will start using Vulkan. So anyway, that's going to do it for this video. Thank you guys so much for watching. I hope you enjoy this series so far, and I hope you're learning from it. If you like the video, go ahead and toss it a thumbs up. If you haven't already, consider subscribing. Hit the little bell for notifications as to when new videos in this or other series drops. And I will see you guys in the next video.